Okay guys, make sure your name, date, and period is on the page. Today we're going to continue factoring trinomials, but we have two special cases. The first special case is perfect squares. A perfect square is when you factor it and you get the same binomial twice. For example, if the answer would turn out to be x plus 2 and x plus 2. That's the same binomial twice. It's a perfect square. You could also write it as x plus 2 squared. So let's do an example. This trinomial does not have a coefficient, so we don't have to use the slide, divide, slide method. We simply go straight into factoring. It has an x squared, so we know the first component has to be an x. We list our factors of 4, 1 and 4, 2 and 2. We pick the pair that adds to give us 4 in the middle. That would be 2 and 2, so it's plus 2 plus 2. Therefore, it's a perfect square because we got the same binomial twice. You certainly can write it as x plus 2 squared. Alright, for example 2, I'm actually going to substitute it with number 2. So you can do example 2 on your own, but we're going to work through example 2, number 2 right here. When we're doing our factoring and you know it's a perfect square, you are more than welcome to say what would give us 4c squared. Well, that would be 2c and 2c. That's 2c times 2c would be 4c squared. How would we get 9? We would get 9 by having a 3 and a 3. 3 times 3 is 9. And then, since the middle is plus, we're going to put a plus and a plus. If you were to factor it, FOIL it, you're going to get 6. Not 6. I tried to do FOIL the O first, outside. It's first times first. That would be 4c squared. 6c, 6c, and 9, and that's where we see we got the 12 from 6 and 6. 4c squared plus 12c plus 9. So that was our answer. So the answer itself is the factor part, so that would be 2c plus 3 squared. That's the perfect square. So all of these problems on the page are going to end up having the same thing twice. That's what makes it a perfect square. So you don't have to use the slide, divide, slide rule on this to bring it over, because I'm telling you it's a perfect square. So you're going to think, what do I multiply times itself to get this? 4t and 4t. That would be the thing that you multiply times itself to get it. What do you multiply times itself to get 25? 5 and 5. It can't be plus like we just put in, because it's negative in the middle. Positive times positive does give me a 25 positive, but it doesn't give me a negative when I add it. So you would know that they both have to be negative and negative, so that when you multiply it's positive, but when you add they stay negative and you have bigger negatives. Alright, so this is perfect squares. That's what you're going to do. Do example 2 and the remainder of the work. Flip over to the back of your page. Now we're doing difference of squares. That's where you get the same numbers, but one's positive and one is negative. For example, x plus 5 times x minus 5. So you're looking for the same number, different sign. How do we know that? Because when we're looking at the problem, it's missing the x term in the middle. There's no x. We're used to it being ax squared plus bx plus c. There's something in the middle. This has to be 0. That's why it's canceled out and we don't even write it. You just have the first term and the last term. That's what makes us know that it's going to be plus 5 minus 5. In this case, what are the factors that multiply times itself to get 36? Not 5, but 6. 6 times 6 is 36. So the factors would be x minus 6, and what would be the next one? Not x minus 6 again, x plus 6. That's what works out there. Looking at our second problem, we see it's still missing the middle term. There's 0x, so whatever it is, it has to be times itself, one positive and one negative. So when you add it, you get 0x in the middle. So what number times itself gives us 36? Well, 6, and times itself gives us x. So that's 6x times 6x would give us 36x squared. And then what gives us 1? Well, 1 times 1. And if it's negative, we know one's positive and one's negative. Same numbers, different sign in the middle. That's what a difference of squares is. So on this back side, continue the rest of the problems, and you're looking for the same numbers, different signs.